Good morning. Yesterday we talked about the different properties of gases. So today we're going to move forward and go over gas laws. Okay, we're going to start with the combined gas laws. All right, the variables in the combined gas laws are P1, which is the first pressure, the beginning pressure, V1, which is the beginning volume, and T1, which is the beginning temperature. We're going to change the temperatures. All right, we're going to change the temperature and change the pressure, and we'll calculate the resulting volume. All right. So basically, with the combined gas law, two of the variables are changed for the final, and then we calculate the third. And all three variables are included in the experiment or question. Now, one thing we have to do is we have to make sure that the temperature is always in Kelvin. So we have to take Celsius plus 273 to convert it to Kelvin. Another thing that must be done is whatever units we start with the pressure and the volume are the units we're going to end with. For example, if you use atmospheres for P1, the unit for P2 would be atmospheres. If you use milliliters for V1, V2 would have to be in milliliters. So you can't just randomly pick a volume, for example, have milliliters on the left and decide that it's going to be liters on the right. You're going to have to convert and make them the same. So those are two things that you have to remember. Temperature is always in Kelvin, and P1 has to be the same units as P2, and V1 has to be the same units as V2. So let's go on to the next one. All right, Boyle's law is the next law we're going to talk about. And pressure is inversely proportional to the volume when temperature is held constant. So since temperature is being held constant, it isn't included in the equations. And pressure is inversely proportional. That means as pressure goes up, volume goes down. Okay, so as pressure goes up, the volume will go down. If you think about a balloon and you add pressure by squeezing it, the volume of the balloon will get smaller. And if you increase the pressure, the volume of the balloon will get smaller until the pressure is so great that the balloon will break. So this is Boyle's law. P1 V1 equals P2 V2. And you use this equation when the temperature is held constant. So the temperature does not change. All right, next one is Charles' law. And the volume of the gas is directly proportional to the temperature. So, again, temperature must be in Kelvin. And what directly proportional means that as the temperature goes up, the volume goes up. So if your temperature goes up, your volume goes up. And when water boils, if you think about it, as water boils, it expands. So the volume will go up the hotter this things get. Things expand when they heat up. Let's go to the next one. The next one is Gay-Lussac's law, and the pressure and temperature of the gases are directly related, provided that the volume remains constant. So this one, the volume remains constant, so it is excluded from the equation. And as temperature goes up, pressure will go up. Because you're holding the volume constant, so instead of increasing the size, what happens is you increase the pressure because there's more collisions against the container's wall. Pressure is caused by collisions of the molecules and collisions against the walls of the container. So temperature goes up, causes the molecules to move faster. Faster molecules have more collisions with the container. So this is the fourth gas law. And the fifth gas law is for a gas at a constant temperature and pressure. So now the temperature and pressure are constant. The volume is directly proportional to the number of moles of a gas. So the number of moles of a gas. All right. And N stands for the number of moles of a gas. So, and then finally is the ideal gas law. Now, on the previous one, there was a change. There was a change in temperature. There was a change in pressure. There was a change in volume. The ideal gas law, there is no change. It says, what the ideal gas law says, at this pressure and this volume and this number of moles, R is a constant, the temperature will be, if you're solving for the temperature, again in Kelvin. So pressure is in ATMs most of the time. Volume is in liters. N is in moles. R is proportionality constant. So R is a constant. R is a constant depending on the pressure. So if pressure is in ATM, the number would be 0.8206. And of course, again, the temperature is in kelvins.